Yeah, look, if you remember a while back, we also looked at this circuit here, or this is at least part of the circuit. It was a motor drive circuit. The circuit was really used to control the direction of the motor. Look, take a closer look at this. Okay, now if you can sort of see this here, what I have really here are 1, 2, 3, 4 transistors. Now really it's these 4 transistors that are actually used to control the direction of that motor. It's really referred to as an H-bridge, this particular circuit. Now this lead here would actually connect to the motor, and then this lead would be the other connection to this DC motor. If you notice that we actually have in this circuit diodes. We have a diode here which is actually connecting really to this lead here that goes to the motor. And then we have a diode here that's connecting to that lead, and then on the other side we have a similar sort of thing. So we have this diode here and this diode here. Now these diodes are really used to protect the transistors. So this is an application where we're using diodes for protection. Well, look, let me just draw part of that circuit that I was just showing you there. So really what we had, if you like, was a 12-volt power rail here. So that was 12 volts, and let's say over here we had ground, which was at 0 volts. So between here and here we have 12 volts. Now what we had, and I'll just show really 2 of the transistors there, but what we had is a transistor sitting here like this. Now we haven't actually discussed transistors at this point. At the moment I just want you to think that the transistors are basically switches. Okay, so we have 2 transistors then. These are symbols for a particular kind of transistor. And then we had one lead that was connected here which went off to the motor. So this lead was one of the leads that went off to the motor. Now, what we had also were these diodes, and that's the bit I really want to focus on. And so what we had between that 12 volts and this output from this transistor pair here is we had a diode, and its connection was basically like this, okay? And then on the other side, also connected to that same output, we had a diode that was connected like so. All right, now these diodes are used to protect these transistors from the effects of the motor. So in essence, what that means is that this output voltage here basically cannot get much higher than this 12 volts due to the presence of that diode. In fact, that output can only go up to 12.7 volts if we're assuming that that's a silicon diode and we're using the second approximation. So once this output has reached 12.7 volts, then basically this diode is conducting, and we can only have a 0.7 volt drop across it. So this can't go any higher than 12.7. Similarly, this diode here, okay, is also going to protect really this transistor, and this output here cannot really go any less than minus 0.7 volts. And let's look at that situation. If this goes to minus 0.7 volts, this diode is then conducting, and so we have a 0.7 volt drop across it. So really these diodes are protecting these transistors. They're really making sure that this output cannot rise much above the 12 and cannot fall much below the 0.